let's get in. Okay, so we'll be looking at some properties of set operations. So let A, B, and C be some three intersecting subsets of a universal set U. So we can write the following results. We can write commutative property. So sets also have commutative property. Let's look at how it is being denoted. Okay, so A intersection B is equal to B intersection A, as we can see on your screen. So this is a commutative property stating that even if I have A intersection B and I turn it to be B intersection A, I can still have the same results. And if I have A union B and B union A, I can still have the same results. Why? So I can simply say that the intersection and then the union of a set are what? Commutative. I can say the intersection and the union of this set is commutative. For example, I have A is equal to 2, 3, 4, B is equal to 1, 3, 5, 7. Then I have A intersection B to be what? 3, and B intersection A to be the same 3, so it is commutative. That's one property. Okay, and when I take it with the union, I will still have the same answer. So that's one property. Let's move to the next property. We have the associative property, and the associative property is stating that if I have three sets, okay, if I'm having three sets, and these three sets, I will put the first two sets in a bracket. So A intersection B, as I will take it as one set intersection C, and I can still turn it as A intersection B intersection C, and the B intersection C will be one set. And if I work on it, I will get the same answers. Why? Because they are associative. Okay, the same way. If I use it on the union, I use the union set, I will have the same thing. That shows that A intersection and union of the sets A, B, and C are what? Both associative. For example, if I have A is equal to 2, 3, 4, I have B is equal to 1, 3, 5, 7, and C is equal to 3, 4, 5, and I work on it using my intersection, I will have 3, and I turn it this way, I will have the same 3. So this is called the associative property. Let's look at our distributive property. The distributive property also works the same way, but in this case it will be a slight difference. In the associative, we have the sign here, that's the intersection, to be the same on here. That's the one in the bracket is the same as the one outside the bracket. That's for associative. But when we come to distributive, the one outside will be different from the one inside the bracket. So when we look at this one, we have A union into bracket B intersection C, which is equal to what? Then if we have this, we have to split open it into A union B in one bracket intersection A union C in another what? Bracket. And I can still do like bring the intersection out and put the union in, and I will have A intersection B union B intersection C. So that's how it works. Let's see. So if I have this, therefore union set is what? Distributive over intersection. Why? Because it was inside the box. So union set is distributive over the intersection. The same way, if I bring the union set here, okay, the union set inside the box and bring the intersection outside, I will say that the intersection is what? Is distributive over the union set. So that is how it works. Let's look at an example. We have A union B intersection C is equal to what? A union B intersection A union C. Then I'll have from what we were given here as A is equal to 234, B is equal to 1357, and C is equal to 345. I'll just place them in, and my final answer should be 3, 4. Okay, and the same way, as getting my answer to be 3, 4, I can conclude that the union set is what? Distributive over the intersection. Okay, now this is an example. If P is equal to 3, 4, 5, 6, Q is equal to 5, 6, 7, 8, and R is equal to 2, 3, 7, 9, find Q intersection R, P intersection Q union R, P. So this one is very simple. Okay, so let's look at how to solve this question.
Okay, so probably this is our last example we are taking. Okay, so in the question we were given P and members of P or elements of P, Q and R, and we're asked to look for Q intersection R, P intersection Q union R, and so this is how you go about it. Okay, so we first looked at some examples which we are having all these things. So I just intentionally did this one so that you have more detailed understanding. Okay, so Q intersection. So we have Q and we have R. So any members found in both is the intersection, and we can find 7 and 7 there. Okay, and we are to look for P intersection Q union R. So you first look for the one in the bracket, and this is what we have because we combine them. Okay, and then you find the intersection between the elements of P, and you get your answer. Okay, and we are asked to find P intersection Q. P intersection Q is equal to this. Why? Because they are found in both sets. So 6 here, 6 here, 5 here, 5 here. And we are asked to find P intersection R. So P intersection R, you can find 3 here, 3 here. Okay, so that is 3. Okay, there's 3 here. And we are asked to find P intersection Q union P intersection R. So P intersection Q, here we had 6, 5, 6. So we bring it here, 5, 6. Okay, and P intersection R, we have 3. So we just find it. Okay, so that's it. Very simple. So you do the next examples I'll be bringing, and I'll be glad you send your answers to the comment section.
Okay guys, so this is the solution to example 2.9. So let's move. So I will let you to test yourself on these questions. Very simple questions. Let A is equal to 2, 3, 5, 8, B 2, 5, 10, 12, and C 2, 4, 5, 7, 10. And you'll find B union C, A intersection B union C, A intersection B, A intersection C, A intersection B intersection A intersection C. So very interesting questions. So you can bring or type your answers in the comment section. Like, share, subscribe to the video. This is Legend in Learning Digital Class. We will see you again. Bye bye.